So after we have this regression model, the next question will be how to explain those parameters, how to explain the B1 and B0. So B1 is the one next to the independent variable. So the B1 is whenever we increase the independent variable by 1, so the y hat or the estimated y value will increase by 0.0678, or in other words, the estimated y value will also increase by B1. Okay, so that's how we explain the B1, B0. So when we set x1 or the independent variable as 0, we will have the intercept or the B0. So in this case, if the driving distance for driving assignment is 0 miles, which means this is 0, then the mean travel time will be our B0, 1.2739 hours. So that's how we explain the intercept. So let's talk about two terms. One is called experimental region. So what is this region about? So that's the range of values of the independent variables in the data used to estimate the model. So in our case, let's get back to the data we have. So those are the X data we use to formulate the regression model, and the experimental region is, so what the smallest number is 50 and the largest number is 100. So from 50 to 100, that's our experimental region. And next term is called extrapolation. So let me see if the pronunciation is correct. Extrapolation. Okay. So it means the prediction of the value of the dependent variable outside of the experimental region. So what does that mean? So we know the experimental region is from 50 to 100. What if I want to predict the travel time given the miles traveled as 200? So 200 is outside of the region. So if I do this prediction, it's going to be risky because this regression model is based on the data under this range. So if we want to predict some value here using this model, is risky. We are not sure if this data is valid or not for predicting a value that is outside of this range. Okay. So that's a term. And then let's talk about some errors or the residuals. So for each of the x value, we have a corresponding actual y value or the observed value, and we also can enter those values in our regression model to get the estimated value. Then for each point, we can get the residual. For example, if we want to calculate the residual for the first assignment, so the miles is 100. If we put 100 there, so the estimated value or the average or the mean travel time would be 8.0539, but the actual travel time is 9.3 hours, and we can calculate the residual, and we can do the same for all the assignments. So in Excel, let's do this calculation. We will use those data later. So let's calculate the residuals for each of the assignment. So we have the miles. Let's say, okay, that's as variable, or this as data. So the time is y data, so actual y data. Okay, so y. Well, let me see. I cannot type in hat, so I just say estimated. Okay. So how do we get the y estimated? Because we have the regression model. Let's put in the regression model here. So it's equal to B0. So B0 is 1.2739 plus the slope, which is 0.0678 times the x value. X value is here. Okay. So it's here the estimated value. I do the same for the rest of the assignment. Okay, we have the estimated value. And the next one is to calculate the residual. So E is equal to the actual or the observed value minus the estimated value. Okay. Then we do the same for the rest of no. Okay. And then we calculate the E square. Okay. So we just calculate the square of the E. Let's do the same for the rest of the data. So let me save data. Okay. So let's save it for now. So we will use that later. One more thing we want to do is to calculate the total. Okay, we are missing the total. So the total, let's see, total here. Calculate the total for all of them. So it's equal to just sum, and we do the same for the rest of them. Okay, so we are good for now. So then if we plot the residuals in the plot, so this is what we have. So this is the regression line. And here if we look at the fifth assignment, here is the actual or the observed data or the historical data, and compared with the estimated value. So this is a y hat. Okay, so we can do this to all the values. And the E square, so that's we have to square the residual. So basically it's the area. So it's the area because that's a square. So if we add up all the area of the squares, we will have the total number. Okay, I have to change this. Total. My apologies. Then how to use the Excel to do this calculation? We already did that. So we have the scatter plot, we add the trend line, and so on and so forth. I will skip those, so we have the same figure. Okay, if we want to have a mathematical formulation for B1 and B0, here is the expression. So we get the B1 first. So how do we get the B1? We need to use each X data and the average of the X data, Y each of the Y data, and the Y bar, which means the mean value for the dependent variable or the Y data. Okay, so after we have the B1, we can calculate the B0 using the second expression. But here we have Excel, we don't have to manually do the calculation, but here is a mathematical expression for that. Then the next topic is about the fit of the simple linear regression model to the data. So how well the model or our model can fit the data we have. So we have the model here, and here's the data. So how well this model fits the data. So that's the next topic we want to discuss. So in order to discuss the fitness, we need to learn some terms. The first one is called sums of squares. Okay, due to error. So sum of squares due to error. So SSE for short. So if you look at the expression, that's something we just calculated. We already calculated the summation over the residual squared. Okay, so that's the first term we want to learn. So we already did the calculation here. Okay, so that's a value. The value is a measure of the error in using the estimated regression model to predict the values of the y variable in the sample. Okay, and the next one, so before we go to the next one, in this figure we put one line, the horizontal line here, and this line is about the y bar, the mean value of the observed y value, or the mean value of the dependent variable data in the sample. Okay. And here one calculation we did is we want to find the difference between each of the observed y value with the mean of the y value. We want to calculate the difference, and then it comes to the next term, which is called total sum of squares. For short is SST. So SST, the total sum of squares, is equal to the summation over the difference between each of the observed y value and the mean of the y value squared. So that's the SST. And the SST, we haven't calculated that yet, so right now let's do the calculation. So here's where is the y value, where is the y bar. So we haven't calculated the y bar yet. So let's do this calculation. So it's the average over the y data. So let's not include the total, so we just want to calculate the average. So that's average. Let's have one more term, which is y minus y bar. Let me just use this bar. Okay. So it's equal to the each of the y value minus the average. So I need to fix the location of the y bar. So I put a dollar sign before 13, and then I can just drag it. Okay. And then the next column, I want to calculate the difference squared. Okay, we are just want to square the previous one. And that's it. So this one I need to delete.